Moving on with solving exponential equations, day 2. So today we're going to get a little more involved, and the first thing we're going to talk about is rewriting powers with the lowest possible base. So you could generate a list of powers in the calculator. So for instance, to get the powers of 2, graph the function f of x equals 2 to the x power and see the table of values. So what would that help us with? The first section says rewrite the following numbers as powers of 2. So we want to rewrite all these numbers here as a power of 2. So I'm going to put 2 to the x power. So if I'm talking about powers of 2, I'm going to talk about an exponential function with a base of 2. And now let's create a table of values. We'll go from 0, I don't know if it's going to let me go to 100, and it does. The numbers get huge, even with a low base like 2, very quickly. But if I scroll down, the x values are like the exponents, and the y values are your powers of 2. So I'm going to list right here. I'm listing the f of x column. 1, 2, 4, 8, 16, 32. These are all your powers of 2. 64, 128, 256, and so on. So this is how we could use the calculator to help us with powers and solving exponential equations by getting common bases. 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Okay, so number 1 was rewrite 32 as a power of 2. So I see from my list that when the input is 5 in the calculator, the output is 32. So that means 2 to the 5th power is 32. So for number 2, we want to rewrite 2 to some power for 32,768. So let's scroll down this list and see when we're going to have a power of 2 that's equal to 32,700. Tell me, right here. 32,768 is when the input is 15. So that means 2 to the 15th power is equal to 32,768. So we could rewrite that number as a power of 2. How about 1 over 1,024? Well, anytime it's in the denominator, that means the exponent's going to be negative. But now let's find what input gives us an output of 1,024. I see when x is 10 on the list. Do you see in the calculator screen? I can't point to that. When x is 10, right on top, y is 1,024. So that means 2 to the 10th power is 1,024. 2 to the negative 10th power would be 1 over 1,024. So that's rewriting numbers as a power of 2. The next section, I want you to rewrite numbers in the as powers of 7. So I would want 7 caret x. And now the table of values will give me all the powers of 7. These numbers get even bigger quicker. Okay, exponential functions get bigger fast, exponentially. So 2,401 I see on my list. When I'm going to scroll all the way up to the top. When x is 4, the output's 2,401. That means 7 to the 4th power is 2,401. How about this 40,000 number? I don't even have to scroll down that far. Right at 9. So 7 to the 9th power is equal to 40,353,607. Now the 1 over 343, since it's in the denominator, I know I'm going to have the base of 7 with a negative exponent. I'm going to scroll up to see what the input is. 7 to the 3rd power is 343, so 7 to the negative 3rd power is negative 1 over 343. So this is extremely important for you to understand in order to solve the equations we're doing today. The next section takes it a step further. Rewrite each pair of numbers as a power with the same base. So we have to figure out how we could rewrite these numbers with the same base. So I want to utilize the calculator. We know how, if we're talking about the number 4, 4 is a power of what? We could write it as 2 squared, or we could leave it as 4. Let's see if I list the powers of 4, 4 caret x. If I look at this table, is 256 on this table? It is, okay? If you look right here on the table, that when x is 4, the output's 256. So you actually have 2 options for number 7 here. We could write that they're both could be powers of 4, 4 to the first power, and 256 is 4 to the fourth power, okay, because the table of values here tells me that when the input's 4, the output's 256. Or, since you know that 4 is 2 to the second power, you could also check, could we rewrite 256 as a power of 2? Let's check it out. Look at the table of values, and yes, when the input's 8, the output's 256. So this is 2 options. You could use a base of 4 and get them both with the same base, or a base of 2. Number 8 and 9, you're not going to have that option. There's only going to be one way you could write both numbers with the same base. Sorry, the number looks a little confusing. 8 and 16. Well, what number could you use to write 8 as a power of a different base? You could even have your powers of 2 in the calculator. Look at this. I could do powers of 2, powers of 3. Oh, sorry, I don't know what I just did. I want 3 and then an exponent of x. Powers of 4, so 4 with an exponent of x. Powers of 5. I'll do powers of 6, and then I'll stop. But you could do them all. Then I could create a table of values for each of these, right? Go back, table of values. Go back, table of values. Go back. I don't even know which one I hit on. And then go back, table of values. Now, actually, here are your powers of each of the numbers, okay? So f of x are your powers of 2, your powers of 3 here, your powers of 4, whatever's the second number on the list, that's the base, your powers of 5. So do we see 8 on any of these lists? Yes. If the second number is 2, that's your first power, because I started at 0, so 2 to the first power is 2. So if you look at your powers of 2, 2 to the third power is 8. Do you guys see? I'll scroll up so you see that when x is 3, 2 to the third power is 8. And do we see 16 on that list? Sure we do. When the exponent is 4, it's 16. So 2 to the third power is 8. 2 to the fourth power is 16. So you're able to write 8 and 16 both as a power of 2. The next one, we have 1/9 and 81. Well, what could we write those both as a power of? Well, 9 is in the denominator. I didn't go all the way to the 9s on my table. But if 9 is in the denominator, do we all realize that we could write that as 9 to the negative first power? And 81 is 9 to the second power. So we could rewrite those both as a power of 9. So that's what you're going to have to be able to do for these equations. Figure out what base you could rewrite both sides so that there's a common base. So we're going to be doing 4 together, and then the next you're going to try on your own. And I truly hope you're trying them on your own, because that's going to be the only way you learn. For number 10, my bases here are 9 and 27. We have to figure out how we could rewrite those two numbers with the similar base or the same base. So I'm going to go back to my calculator actually right now. Okay, and I'm going to look at my powers of 3, which is my G column. All right, I see 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. I'm looking down that G of x column in my calculator. So 9 we know is 3 to the second power. 27 is 3 to the fourth power, if you see it down the list. So I'm going to rewrite 9 is 3 squared. So instead of writing the base of 9, I'm writing 3 squared, and then I'm going to bring down that exponent, 2x minus 5, right outside the parentheses. 27 is 3 to the third power. There was no exponent there to begin with, so I don't have to bring anything down. Then I simplify using power to power, just like we did on Friday. So the base of 3 is going to come down, and I'm going to multiply the inside and outside power and get 4x minus 10. You have to remember to distribute when you're multiplying the inside and outside powers. Then the 3 to the third is just going to come down. There was no other power. Once we have the common bases and the exponents are simplified, we could drop the base, set 4x minus 10 equal to 3, and then this is a very basic equation that you could solve, adding 10 on both sides. I get 4x equals 13, and then I'm going to divide by 4 on both sides, and I'm going to get x equals, I can't do 13 divided by 4, so I'll just write 13 over 4. Final answer. Number 11. Okay, how could I rewrite 1/4 and 8 to have the same base? Anybody think of a number we could use to rewrite 4 and 8? Those are both powers of 2. If I look at my F column, I have 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. Those are my first few powers of 2. So how am I going to rewrite 1/4 as a power of 2? Well, 4 is 2 squared, right? But since it's 1 over 4, I'm going to make it 2 to the negative second power. 2 to the negative second power is the same thing as 1/4. And then I'll bring down the x that was there before. On the right-hand side, I could rewrite the 8. So all we're rewriting are these bases using a base of 2. Again, I'm going to use a base of 2. 8 is 2 to the third power. And then I'll bring down the 1 minus x. Now I'm going to simplify multiplying inside and outside powers. So the negative 2 times x is negative 2x. On the right-hand side, I have to distribute. I get 2 to the 3 minus 3x. And then I have the common base that could be dropped. Negative 2x equals 3 minus 3x. And now I'm going to solve this equation. I'm going to add 3x to both sides. And I get x is equal to 3. Final answer. Okay? 2 more that we're going to do together, and then you're on your own. Looking at these two numbers, how are we going to rewrite 3,125 and 25 as a power of the same base? What number do you think of when you see the 25? You could write 25 as a power of 5. So I'm going to scroll down to my list of my powers of 5. Okay, 5 to the 0 power is 1, 5 to the first power 5, 5 to the second power 25. So I'm going to rewrite the 25 as 5 squared, and then bring down the 3x minus 5 outside the parentheses. On the left-hand side, instead of the 3,125, I'm going to scroll down, and I see that that is 0, 1, 2, 3, 4, 5. The 3,125 is the 6th number on the list, so that's a power of 5. So I'm going to put 5 to the 5th power. Okay, so we said 0, 1, 2, 3, 4, 5. Yep, 5 to the 5th power is the 3,125, and then bring down the x plus 3. Then I could multiply the inside and outside powers. 5x plus 15 on the other side. 5 multiply. I get 6x minus 10. Okay, in Algebra 2, you're going to have to be able to do this. Common bases get dropped, and now I just have to set the exponents equal to each other, and then isolate the x. So I'm going to minus the 5x on both sides. I get 15 is equal to x minus 10. Add 10 to both sides. I get that 25 is equal to x. Final answer. Next one. So I like to look at the smaller base first. The two bases is 1 over 1296 and 36. Looking at those two bases, I could think that 36 is a power of 6. So let's look at the list of a powers of 6. That's the last one I had put down. The third number on the list, that's 6 to the second power, right? Because I go 6 to the 0, 6 to the first, 6 to the second. I could have maybe started my tables at 1 with an input of 1, so that the 6 would be the first number. 6 to the first power, 6 to the second power. Let's see if we could find that 1296 on the list. I do see it. It's 1, 2, 3, the fourth power. So 6 is going to be the common base here. 6 to the fourth would be 1,296. So I'm going to be making it 6 to the negative fourth to make it 1 over 1,296. And then negative 5x plus 14 comes down. Equals the 36 is 6 squared. And then I'm going to bring down the negative 4x plus 9. So again, I'm going to multiply the inside and outside powers. I'm going to get 20x minus 56 equals 6. Distribute the 2 here. Multiply the inside and outside powers. Negative 8x plus 18. I'm going to drop the bases. That's my son trying to distract us right now. I'm going to ignore him. 20x minus 56 equals negative 8x plus 18. And then I'm going to isolate, add the 8x on both sides. I have 28x minus 56 equals 18. Add 56 to both sides. 28x equals 74. Divide by 28 on both sides. And what's this going to leave us with? 74 divided by 28. I'm going to leave as a fraction. I don't know if it could be reduced. X equals 74 over 28. Final answer. Okay, so now looking at these that I left you with, they're not very difficult to get a common base. The numbers are reasonable. So look at the bases, come up with a common base, rewrite both sides with the common base, multiply the inside and outside powers. I'll see how you guys do today and decide if we're moving on tomorrow or spending another day on this, because this is important.